Hello everyone. Once again, I'm Erisa to take you through some online mathematics lectures. Last time, I discussed the concept of polynomials. We went ahead and talked about the remainder theorem. This is what we said last time. If you have a polynomial f of x, okay, and you divide it by a linear factor x minus a, you will get another polynomial g of x plus a remainder r still to be divided by x minus a. We say that if you go ahead and cross multiply everywhere by x minus a, you'll have f of x is g of x into x minus a plus r. Now, if x is equal to a, then f of a will be equal to g of a into a 0 plus r. But you know, g of a times 0 is 0, so it means that the remainder is f of a. Now, the concept of factor theorem develops from the remainder theorem. Okay, r is equal to f of a. If our r is equal to f of a equals to 0, okay, that means that substituting in x is equal to 8 gives a 0 remainder. Then it means that x minus a is a factor of f of x. So today I want to discuss the concept of factor theorem. It develops from the remainder theorem. Simply, the factor theorem is remainder theorem with the r as equal to 0. Okay, so let's write something small about the factor theorem, and then we see how we can use the factor theorem in discussing this part of polynomials. Okay, and how we use the factor theorem to factorize polynomials. The factor theorem states that if f of x is a polynomial and substituting x is equal to a gives a remainder of 0, okay, then x minus a is a factor of f of x. Okay, as I've explained, this develops from the remainder theorem. So if you get 0 remainder upon substituting x is equal to a, then x minus a is a factor of f of x. And now, how do we use this to solve or to factorize polynomials? Let's see an example. Let's consider this polynomial. We have consider f of x equals to x cubed plus 2x squared minus 14x plus 12. Okay, so f of 2 is equal to 2 cubed plus 2 into 2 squared minus 14 into 2 plus 12. Okay, 2 cubed is 8. 8 plus 8 is 16. Okay, 16 plus 12 is 28. Okay, now 28 minus 28, this is 28 minus 28, okay, which is equal to 0. So f of 2 is giving us 0. What does it mean? It means that, okay, f of 2 equals to 0. Okay, this means that x is equal to 2 is a root of x cubed plus 2x squared minus 14x plus 12. And the x minus 2 is a factor of, okay, so x minus 2 is a factor of that polynomial. Okay, so how do we now go ahead and factorize polynomials using this concept of factor theorem? Let's see an example. Basically, what we are learning from the factor theorem is that when you substitute a particular x value in a polynomial, a polynomial defined in terms of x, okay, if it is defined in terms of y, substitute y values. But for this case, we are sticking to x. Our polynomials have been defined in terms of x. So if you substitute a particular x value into the polynomial expression, and then you end up with 0, that x value is the root, okay? And to get the factors, get x minus that value, okay? So let's look at this example. Ladies and gentlemen, we have this example that is, tasking us to factorize that polynomial. Now, we don't have any clue about which x value to substitute in the polynomial, and we get 0. But there is an idea. If we write this polynomial in a nested form, we can simply develop an idea about that x value. So let's write the polynomial in nested form and see if we can try to have a guess of the x value, which we can substitute in and we get 0. Okay, so in nested form, we are going to have f of x equal to, this is going to be 2x minus 9. Okay, I will multiply this by x, then plus 7. I multiply this by x and add a 6. That is simply writing the polynomial in a nested form. So the nested form can really help us a lot. We are saying that if we substitute a particular x value in this polynomial, we must get 0, and that x value will be a root, or x minus that value will be a factor. So in this case, something must be, something here must be added on 6 to give us 0. Okay, that means that whatever is coming from this part must be a negative 6 if we are to have a 0. So if that's a negative 6, we know that this is a product of, we are having the product of the inner part here, and we are multiplying it by x. Okay, so this inner part and x, they must be factors of 6, because if you are to have a negative 6, then x times this part, okay, must give us negative 6. So x could either be a 2 or a 3. Let's try one of those values, substituting in x is equal to 2 or x is equal to 3, and see if we shall end up with a 0. So what is it? What is f of 2? F of 2, this is going to be 2 into 2 minus a 9. What we get, we multiply by 2. Okay, then plus a 7. Then what we get here, multiply it by 2 and then add on 6. But 2 minus 2 times 2 is a 4. And the 4 minus 9 is negative 5. Okay, then negative 5 times 2, you get negative 10. Okay, then negative 10, that means the whole of this part is giving us negative 10. Add on 7, you get negative 3. Negative 3 times 2 is negative 6. So this is negative 6 plus 6, and therefore we have 0. So we are lucky, substituting x is equal to has given us 0. This means that, okay, x minus 2 is a factor. Now, if x minus 2 is a factor, how do we find the other factors? Because the question is tasking us to factorize the polynomial. So how do we find the other factors if x minus 2 is a factor? The idea is use long division to always produce for you the best results in this case. So let's carry out the long division and see how we can further factorize this polynomial. Okay. We have been given our polynomial, which is 2x cubed minus 9x squared plus 7x plus 6. We are now to divide this by x minus 2. Since x minus 2 we have discovered is a factor, okay? So we get 2x cubed and divide by x. This gives us 2x squared. So this is 2x squared. Now the 2x squared multiply through by x minus 2 to give us 2x cubed minus 4x squared. So this is 2x cubed minus 4x squared. Let's subtract, okay? Be careful when you are subtracting, okay? There is a bracket here which we don't always put, but if you want for convenience, always put that bracket. It is going to help you a lot, okay? So when you subtract, this is going to be 0, okay? Then this is now a positive 4, so we have minus 5x squared plus 7x plus 6. Now we get the negative 5x squared and divide it by x. What do we end up with? Minus 5x. So this is a minus 5x squared plus 10x. Okay, remember we are getting negative 5x and multiplying by x minus 2. So we have minus 5x squared plus 10x. So let's subtract. What do we get here? If you subtract, this is a 0. Okay, this will become a negative 10. So you have a minus 3x plus a 6. So we get negative 3x and divide by x. What do we get? Minus a 3. Okay, so this is minus 3x plus 6. So when you go ahead and do the math, I think you're going to end up with a 0 remainder. Okay, so we have that done right now. First, erase my blackboard. Okay, so what does it mean? This means that my polynomial, which is 2x cubed minus 9x squared plus 7x plus 6. If I divide it by x minus 2, it is giving me 2x squared minus 5x minus 3. Okay, and the remainder is equal to 0. Remember our remainder theorem, we are supposed to say the plus a remainder, but now in this case the remainder is equal to 0, so there is no need of including it. So if we go ahead and cross multiply, you have 2x cubed minus 9x squared plus 7x plus 6 is now x minus 2 into 2x squared minus 5x minus 3. So far, we have factored it that level, but still, this is a quadratic. This part is a quadratic, which you need to factorize, okay? And remember, we have discussed the quadratic equations and how they are factorized, so that's not a big issue to us. We know what we do when we are factorizing quadratic equations. So let's go ahead and factorize that part, and then we will be done with what we wanted to discuss today. So let's go ahead and factor this part, okay? To factorize that quadratic, look for two numbers that sums to negative 5 and the product is negative 6. And those two numbers are negative 6 and negative 1. Okay, negative 6 and a positive 1. So let's factorize it. This is going to be x minus 2 into 2x squared minus 6x plus x minus 3. Okay, and if you really know what you're doing, this minus x minus 2 into 2x x minus 3 plus x minus 3. Okay, so the final answer is x minus 2 into 2x plus 1 into x minus 3. Okay, that's now the polynomial 2x cubed minus 9x squared plus 7x plus 6, fully factorized using the factor theorem. We have done it, ladies and gentlemen. We have used the factor theorem to factorize our polynomial. It is now fully factorized. Okay, maybe just one more example. You know, as a student, you always get an idea. but there will be problems you encounter on the way. And to be strong, you keep working out. You don't have to be so timid, in approaching problems. Always go as a brave person and solve these problems. You'll always have problems as long as you're a student. Okay, there will be no easy day for you. That is it, simply. All right, so let's look at another example. Example 2. Example 2. What is in this example 2? What do they want us to do? Let me write it down. So we are required to factorize 2x cubed plus 3x squared minus 32x plus 15. Okay, let's go ahead and factorize this. So what do? We have a task of factorizing 2x cubed plus 3x squared minus 32x plus 15. The idea should be, if you want to have the guess of the x values, that you can substitute and get 0. This should be the idea. Write this in nested form. This is 2x plus a 3 multiplied by x, okay, minus 32, okay. Now multiply the whole thing by x, and then after add the 15, okay. So this is where the idea develops from. Whatever comes from this part, when added on 15, must give us 0, okay. So we conclude that this part will give us 15 negative, okay, if we substitute the x value. Now, if that is a negative 15, then one of the x values must be a factor of negative 15. So what do we do? Let's look at the factors. The possible factors of negative 15 here are 3 and 5. That's what I'm saying. So let's try to substitute a 3, okay? Now, assuming this is the f of x equals 2, okay? Let's substitute in x is equal to 3. F of 3 will be equal to, this is going to be 2 times 3 plus a 3. Then what we get multiplied by 3, subtract a 32. What you get, you further multiply it by a 3. Then after, add a 15. What do we get here? Okay, 2 times 3 is a 6. Okay, 6 plus 3 is 9. 9 times 3 is 27 minus 32. Okay, then this multiplied by a 3 and add a 15. So 27 minus 32 is negative 5. Negative 5 times 3, negative 15. So this is a negative 15 plus 15, which is equal to 0. Okay, so if 3 had not worked for us, then we would go ahead and try a 5. But we are lucky, when we substitute 3, it just straightforward gave us 0. And therefore, what does that mean? This means that have to erase, keep erasing. Okay, this means that x minus 3 is a factor of f of x, and to factorize 2x cubed plus 3x squared minus 32x plus 15. Okay, we want to write this as x minus 3, okay, into something here, okay, and whatever will be inside this bracket should come from long division. So let's go to long division. Okay, we can also go ahead and try to, but that's going to be a long way. The easiest way is always to use long division. Just going to give you this part so fast. So let's try long division and see what we get. So let's count the long division so we can factorize our polynomial. What are we doing? The long division. We have been given 2x cubed plus 3x squared minus 32x plus 15. We are to divide this by x minus 3. So since we have done long division, the first example, here we are going to be so super fast. So 2x cubed divided by x to get 2x squared. So this is 2x cubed minus 6x squared. Let's subtract it. We get, this is a positive 6, so it is a 9x squared minus a 32x plus 15. It is a good idea to add the zeros to these other parts so you can easily make your subtraction a bit very simple. Okay. So what do we do? Let's go ahead and divide 9x squared. 9x squared divided by x is plus 9x. Multiply through. You have 9x squared, okay, minus 27x, okay, and that's what we have, then plus a 0. So let's subtract it. When you subtract 27 and that negative 27, okay, and the minus 32, you end up with a minus 5x plus 15. So 5x divided by x, this is minus 5x. So this is going to be minus 5x plus 15. When you subtract, of course, you get 0 as the remainder. It must always come to 0. If this part was a factor, then it will always come to 0. So what does it mean? This is what it means. Okay, let's go ahead. The major part of looking at long division is to factorize the factorize the quotient. So we have 2. This means that 2x cubed plus 3x squared minus 32x plus 15 is the same as x minus 3 into 2x squared plus 9x minus a 5. Okay, I'm sorry, this part is a 5. This is not 5x, it is simply 5. Okay, so this is not 5x. That is a big mistake. Okay, but we always make those small mistakes as mathematicians. So this is 5. That's why it's always good to go through your work, because nobody is so perfect. You always make mistakes in the process of calculation. So when you calculate something, always try to go through. These small mistakes can always cost us big. Okay, so let's go ahead and factorize this other part, but you know that's a walkover. It's the chicken and egg problem, so you should not really have a lot of difficulty trying to work out that. So here factorization of quadratics comes into use. We have this as x minus 3 into 2x squared plus 10x minus x minus 5. There are two factors. You look for two factors. Their sum must be 9 and the product negative 10. So that is negative 10 and negative 1. So go ahead and further factorize this. You have x minus 3 into 2x squared. Why do we still bother with our 2x squared? Let's take this as 2x times x plus 5. Then here we take out a minus and have x plus 5. Okay, so what's the final answer? This is x minus 3 into 2x minus 1 into x plus 5. So we have fully factorized 2x cubed plus 3x squared minus 32x plus 15 as x minus 3 into 2x minus 1 into x plus 5. Okay, ladies and gentlemen, we just need one more example and we call it a day. We have tried to exhaust this part But as learners, I try to give you as many examples as possible so you can learn something. I want you really to master whatever I teach. When you are being handled by an expert, there is always a difference, and this is the difference I'm talking about. All right, let's talk about example 3. Okay. So example 3, they are giving us a polynomial of degree 4, okay, with the coefficients of x to the 4th and the x cubed as a and b. And they are saying that polynomial, when you divide by x squared minus 1, the remainder is 2x plus 1, okay? So here what comes to our mind is the concept of remainder theorem, okay? So let's see. Okay, dividing a polynomial by some factor, then we get a quotient, and this remainder still to be. Let's make use of the remainder theorem and see if we can really try to solve this problem. They have given us a polynomial ax to the 4th power plus bx cubed minus 8x squared plus 6. If you divide this polynomial by x squared minus 1, you end up with the sum function, let's call it q of x plus a remainder which is 2x plus 1 to be divided by x squared minus 1. Okay, yeah, but remember that x squared minus 1 is a quadratic factor, is a quadratic function which we can factorize. So we can write this as because I want to economize my blackboard, let me try to erase this and write it as x minus 1 into x plus 1. Okay, and I further write this as ax to power 4 plus bx cubed minus 8x squared plus 6 as the q of x into x minus 1 into x plus 1 plus 2x plus 1. Okay, that's multiplying through by the divisor everywhere. All right, so what do we do? Let me erase this. Okay, now here we try to see some of the x values that will make n of these brackets 0. So if x equals to 1, then I have a plus b, okay, minus 8 plus 6 is equal to 2 into 1 plus 1, and I think that is just a 3. So my a plus b, okay, this will be a minus 2, a plus b is equal to 5. I can call this equation 1. So let's call this equation 1. A plus b is equal to 5. That's equation 1. Now let's go ahead and try the other x value. Okay, you say if x equals to a negative 1, what happens? This is a, negative 1 to power 4 is a positive 1, minus b, negative 1 cubed is a negative 1, okay, minus 8 plus a 6 is equal to 2 into negative 1 plus a 1. Here you get negative 1, okay? So a minus b will be equal to this negative 2 crossing, when it crosses and go the other side, it will be a positive 2, so you have a 1, okay? So that is the equation, we call this equation 2. Okay, now you solve 1 and 2 simultaneously. A plus b equals to 5. And the a minus b is equal to 1. So what do we do? When you add, the b cancels out. 1 plus a 2. Okay, implies that my a equals to 3. Because that will be 2a is equal to 6. Okay, then 1 minus 2. Equation 1 minus 2 implies that your b is equal to a 2. All right, ladies and gentlemen, that's what we had to discuss today. I have given you this exercise. Okay, go ahead and test your understanding. And I also apologize for the audio. I'm using, a tablet which is not high speed. But when I get money, we'll buy one which has a high processor that can always process information so fast. Or if any of you want to make a donation, you feel free to buy for me one. I really appreciate that. So we can continue helping the nation.